welcome you on behalf of the Dorset branch and also the Hampshire branch and also the e-learning specialist group to this fantastic session that we have ahead of us. Now, as just to remind you, please, to keep muted, etc. And if we've got pressure on the ones, it's better to have your screens off during the presentation, just for the ease of the networking. But when we come into the questions at the end, then please do show your screens up. One of the things we'll ask you to put your questions in the chat, so you can, we're actually not disturbing the presentation as it goes through. Also in the chat, it'd be very nice if you could actually say where you are. So to start with, I'll put in the chat as well, but I'm actually in Bournemouth. So welcome you to Bournemouth on the south coast of England. Now, at that stage, we will be recording this, but I will stop the recording at the end of Teresa's presentation. So the questions and discussions at the end won't be recorded. The recording will actually go onto the website, but this will probably take a few weeks. And again, the slides, the PowerPoint slides associated with this will be put onto the website, again, probably take a week or so. So at that stage, I think we're very, very lucky to have Therese Bings will actually be with us, and I will actually pass across to her to actually do a more formal introduction. But we are very, very glad to have you. Thank you very much.
Cool, thank you. So hello everyone, thank you so much for being here. I am excited to be here and have a chat to you guys. I am a senior software engineer. You might have picked up that I am working for the Ordnance Survey. I joined the OS about 6 years ago, and it was my first real job after university where I did computer science. And today we're here to talk about growing software engineering talent in-house at the Ordnance Survey, and the way that we do that is via the Trainee Scheme. And this is the scheme by which I joined the organization those 6 years ago. So we're going to dive straight in to sort of asking the question, why? Why would we want to grow our own talent? Well, the first part of it is actually about recruitment, getting good software engineers. And we are, like many organizations, are growing faster than we can actually recruit for. It's a very, very competitive labor market, and the move to remote working has absolutely changed the way that we both recruit and work. The next part of it is actually about getting well-rounded people. So when we acknowledge that we're going to invest, when we accept that we're going to do that investment in growing our software engineering talent, we can actually look for different things from our recruitment pool. And we can look for those well-rounded people, the people that have life experience outside of the industry, that can bring a wealth of different experiences and different tools to bear, and make our teams more, introduce a diversity of thought into our workforce and put more tools in our collective tool bag. And another part of it is getting our culture and values. And there are some engineers who've learned their craft in organizations where testing is for scaredy cats, or even worse, testing and deployment are someone else's jobs. And we've worked really hard as an organization to embody that testing and deployment are part of every T-shaped engineer's role. It's part of every engineer's job to do these things. So our trainees learn this from the very start. So that's the why. We're going to spend a lot of this presentation talking about the how. And the first part of it is to acknowledge that we are playing the long game. This isn't a get-rich scheme for us, but it does work. And we are recruiting for aptitude and enthusiasm over experience, and we are growing software engineers on the job. And we've been doing this for about 10 years, and the shape of it has changed in response to market pressures and business pressures. But this is the sort of basic premise under which we have been working. When I'm talking about software engineers, that's my space. So you'll hear me talking about software engineers a lot. But we do this for test engineering, and we are investigating how we can do it for data science in the future. So I'm going to talk about software engineers, but you can extrapolate to test and data science. It's just I'm in the software engineering space. It comes naturally to me. Cool. So this is our approach, and we're going to spend some time digging into the details of what this kind of looks like. So when we recruit, We recruit for aptitude and enthusiasm over experience. And when we invite our applicants to apply, we ask them to focus on 4 kind of key areas. And the first one is we asked candidates to show us that they can take ownership of their learning. Becoming a software engineer and keeping up to date with a diverse and ever-changing technological landscape is really difficult. And it requires people to be able to research and to be able to experiment and learn without handholding. We need candidates to be resilient to bumps on the way and to it being hard and to it not going right the first time. And we need our trainees to organize their learning in a way that lets them build concepts on top of concepts throughout their whole career. We select candidates for their ability to thrive in a group setting. Whilst there are, of course, variations across our different work streams and teams, we are largely a really collaborative organization. You'll often see pair programming and mob programming going on, and lots of healthy debates about the best way to tackle a certain problem. We select candidates that will not only cope, but thrive in those kind of interpersonal relationships. And we draw a distinction between what we call bucket chain teamwork and assault course teamwork. So in a bucket chain from the river to the burning building, you see individuals sharing the load and taking buckets and passing them along, but they're each individually processing in isolation from the other parts of their team. We look for something different. We look for assault course teamwork, where in an assault course, a 16-foot wall is not scaled by a series of individuals, but it has to be done as a team, helping each other over it, finishing the assault course together, crossing the finish line together. And we definitely see software engineering as a team sport. The last thing we look for is a self-driven passion for technology. And it has to be like a genuine affinity for this kind of thing. We're not particularly interested in what specifically they've done or actually their experience or even competence, but there needs to be an internal driving curiosity. Upskilling is hard, and having a proper love of this stuff can ease the bumps along the way and help our trainees be resilient when things aren't going so well. And with the barrier to introductory programming being so low, we do expect trainees, or we expect our candidates to have had a go at something, to have experimented with something because of that internal drive. And generally at interview, we say if people haven't experimented, they're very unlikely to be successful. And an undercurrent through all of this is a sort of emotional intelligence and the ability to reflect. Candidates that can reflect on what practices are working well for them when they're learning are better equipped to sort of tweak what they're doing and make changes to increase the effectiveness of their learning process. Candidates that can reflect on how their interpersonal relationships are or how the group is working are well placed to increase psychological safety and make the methods of work better for the team. And being able to reflect on your own status, on how they're actually doing and how they're feeling, helps our trainees look after themselves and know when to power through something and when actually to ask for help. If you're interested in diving any deeper into this kind of thing, we did write a fairly extensive blog post on our recruitment process and what we look for. And I'll be sharing a link to that at the end of the presentation. So we've gotten quite good at teaching technology, which allows us to recruit for these well-rounded people. So when we're looking for candidates, we are looking for these things that we can't teach. We look for well-rounded people, people that can bring life experience to bear, people that have different tools in their toolboxes from having had different experiences. We look for those constructive behaviors, the things that the kind of people that we want to work with. And that gives us a massive diversity of thought, and we recruit as diversely as our recruitment pool allows. And we often say amongst ourselves that we are recruiting future senior engineers, the individuals that even now, even at their early stages, we can see being leaders of engineering practice, leaders of delivery, and leaders of people. So with all that in mind, what does that actually give us? Well, it gives us lots of things. It gives us graduates and non-graduates. We have people that come to us from computer science degrees and software engineering degrees, but also from spaces like geography and physics and different sciences and all sorts of things. We have lots of career changers. My colleagues who came in through the trainee scheme include a former detective constable with the police, a former nurse. We've got teachers, we've got science writers, we've got game developers, all of these people that can bring amazing tools and experiences to bear. And no one background is best. We don't sort of focus on recruiting graduates from computer science degrees. We champion this kind of diversity, and it makes for a really effective team. So once we've hired, we're looking into the next phase, which is growing our own talent from these raw recruits. So this is growing software engineers on the job. Once we've recruited, there are two ways that these trainees can join our teams. The first is going directly into a team. So in this method, a trainee joins a team. They have a line manager and a mentor, and they work directly on the project from day one. And this produces really specialist engineers who are experts in their space and who can actually return value really quite quickly, surprisingly quickly. The other route that we take our trainees is through something we call the Engineering Academy. And this is when we have small groups, 4 to 6 people at a time, working in a central team for a period before progressing to those same teams that the direct to team trainees joined at the very start. The Academy approach invests in generalists and bringing an early focus on quality and breadth of experience. And these two approaches really complement each other. They let us leverage the skill sets that our recruitment pool offers and means that we're covering lots of different bases when we're building the future engineering teams for our organization. So my involvement is primarily with this Engineering Academy approach, and that's what the rest of this presentation will be talking about. But if you have any questions about the direct-to-team approach or that kind of thing, I'm pretty sure we've got some people on the call who have actually joined via that way that can probably answer the questions at the end. So let's talk about the context and where the Engineering Academy fits. So the Ordnance Survey is a government-owned company, and I'll leave you to look at Wikipedia to understand the slightly complicated definition of that and our relationship to government. The Ordnance Survey is about 1,500 people big. In that, we have many different sort of expert functions and market-facing units, and the one in which I work is called Technology and Design. And this is where, by number, most of our software engineering happens. Technology and Design is about 450 people big, and that includes our out-of-code stakeholders, so our business analysts, project managers, people in architecture. Within Technology and Design, we have several big functions, of which system delivery and maintenance is the biggest. And this is where our main data kind of crunching and egressing happens. So we have data that comes from surveying. That's either through aerial surveying or through people on the ground with GPS staffs. System delivery and maintenance takes that data from raw, derives different data products from that, and egresses that to customers, serves that up to customers at the end. This is where most, not all, but most of our direct to team trainees end up. We also have an IT services domain, and this is where our business IT is supported, and they look after our physical infrastructure in the building where I am presenting from today, and they also look after our on-prem data center. And then we have another team called Common Engineering, which was set up about 6 years ago, along with the start of the Ordnance Survey adopting cloud. And at this point, I'm going to point out that we are an Azure shop, an Azure and Microsoft shop, with lots of Python and C#, and we're starting to do Scala things for big data processing. Within Common Engineering, we have a small team called Developer Productivity, which we will come across, which I'll speak more about in a moment. And this is also where our Engineering Academy starts. The fact that we have our trainees in our central cloud team is really, really powerful, because they learn the platform that everyone else deploys on inside and out. They learn its nuances, what makes it tick, how it all fits together as a relationship, and what it looks like on a platform level. And this is such a valuable thing for them to then take into their teams that are deploying onto that platform. So we upskill our trainees and they take that with them into those system delivery and maintenance teams. Cool. So that's where the Engineering Academy sits. What is the Engineering Academy? The key parts of it are a backlog of important and not urgent work. We maintain this real value-adding backlog of things that are important and not urgent. It is the developer productivity backlog. And this backlog is the things that are the ought to haves, the things that we ought to make time for, and that often we struggle to prioritize against the rest of the business needs and wants. It's the capabilities we feel unprofessional for not having, but we can't prioritize. From this backlog, we've delivered monitoring and dashboards. We've wrapped hard to use APIs and made them tenable for use by other teams. We build and run self-service solutions to replace time-consuming manual processes. And by the nature of it being a platform backlog, anything that we deliver from it has a meaningful impact on all of the rest of the business, a small one, but an improvement. The fact that it's not urgent means that we can let trainees at it, and they can build a thing and they can fail a couple of times and they can do all of that learning and we can do that support. So rather than just trying to rush something out of the door on a delivery deadline, we can let them really explore and lean into the engineering practice that's going to serve them well for the rest of their career. We support our trainees with experienced engineers who work with them fairly intensely at first, and then with the decreasing amount of input and a decreasing amount of direction as the trainees grow in their competence and their experience and their independence. And we bolster this real work, which is what they spend the majority of their time on, with directed and specific teaching interventions, things that we really want that they absolutely have to know, and we teach them in the most effective way and efficient way that we can. And all through it, we're taking a focus on quality so that we are building engineers that know what quality looks like. We're looking for code that's built for long-term cost effectiveness, that's maintainable and extensible, and all of the IBLs. We focus on software architectures that make code easy to change. And we indoctrinate the trainees in test-driven development. And we introduce these quality practices early into their careers so they've got the most time possible to practice or to put them into practice. We embed quality into their engineering, and it forms part of their identity as a professional. But the practicalities of delivering software on a delivery deadline later in their career mean that the trainees will probably make decisions to compromise these in the future. And that's okay. But at least this way, it's a choice. It is a choice to compromise. And it means that they can make optimal compromises that reduce the amount of tech debt that the organization has to accept as a result. So this is part of how we do it. We'll have a look at what we actually cover. And this is there we go. This is a very high level kind of view of what we cover. I have a much more detailed one if people are interested in that at the point where we're doing questions. But we teach them to program. We predominantly work in the academy in C# and PowerShell. Hopefully we touch Python every now and again. And we kind of focus on object-oriented programming. We are big fans of hexagonal architecture. We do TDD. We tend to work in ASP for those that makes sense to. And we couple that with CI, CD, CD. So continuous integration, continuous delivery, and continuous deployment. We teach deployment pipelines, and we expect our trainees to not only write their code, but to productionize it, to deliver it, and to maintain it for as long as they're with us. We also have a big focus on our values and attitudes, and we support our business strategy through these. We're automation first. We are cloud native first. We also talk about team practices, about psychological safety, about the obligation to dissent. So if you see something you think isn't quite right, if you think the team's going down the wrong way, you have an obligation to raise it, and we make it a safe space so that everyone can. And we have a we hold strong opinions weakly held. So if we're asked a question on a preference, we have an opinion even if we're happy to compromise it straight after. Not everything that we might expect to be covered by the Academy is covered by the Academy. And for example, we don't do SQL. And I'm pulling this out to show like just how directed and specific our syllabus or what we cover with the trainees is. We do have relational database in the organization, and actually we have some very big databases, but actually by number, they don't make up the majority. And a lot of our processing is better suited to schema-less databases. So we don't do SQL. But this is a continuous process, and we're always responding to what's new on the market and what the business is trying to achieve. So we are always looking to extend it or retire the things that are no longer relevant. For example, we're now looking at how we can introduce Scala and Databricks, which is a big data processing platform. By building in these values of automation first and cloud native, it's a brilliant way to affect cultural change. We have our leadership leading us towards a cloud native future, and we're building this capability, this strong supportive base layer to support that from the very start, from the very bottom of this. So I mentioned that we have some bespoke teaching interventions, and I'd like to spend some time on those. Particularly, I'd like to share some of the lessons that I've learned that have had a big impact in the way that I do things. And one of those valuable things that I have ever learned in training is that learners don't need simple examples, they need clean examples. And by that, I mean giving learners examples that are clean of context, where the thing that they need to learn is highlighted and distinct from the domain in which they're learning it. What is code and what is the actual domain? Creating short, directed, clean examples in which learners can really understand has been a really powerful tool for us. This isn't a thought that's original to me, and I have lost the source for whoever said this, so if anyone knows, please do let me know. But it's had a profound impact on my practice. The next won't be a surprise to many, but it's the power of narrative, how you can make things make sense by telling a story with it. And the last thing is, it doesn't have to be perfect to be effective. And there are plenty of imperfections in my presentation and my delivery, but I hope it is being effective at delivering some of our messages and that it's holding your attention. So two of these, I've brought out two examples of how we've put these principles into practice, and I'd like to spend some time going through them with you now. So the first one is Azure for normal people. This came out of a conversation on a train on the way back from a conference, where one of our out of code stakeholders remarked that she wished that there was a way that normal people could learn about the cloud. So these are our non-technical stakeholders. They don't need to know the deep darkness of the tech stack, but they have a seat at the table when we're talking about problems, and they have a role to play in making decisions when those problems are framed in the cloud context. So we took it out of the tech stack, we took the cloud out of the cloud, and we brought it to paper. So I'm going to give you an abbreviated, a very abbreviated version of the kind of narrative of Azure for normal people and how we've taken this out of the context of cloud and brought it into the world of paper. So it starts off with the Ordnance Survey having created or sold a new product that we need to now build a system to supply. So assuming all the project prerequisites are taken care of, we have a developer who is working on the system on their laptop. And, and they need to look after their code. They need to be able to revert mistakes. They need to manage their code. So this is what introduces Git to our non-technical stakeholders. From there, they're doing a great job, and their product owner would like to see their code and not have to look over their shoulder at their laptop. So the participants need to work out how to deploy their solution to Azure. So a subscription is Azure's biggest boundary in Azure resources. So the participants go and collect a large piece of paper to represent the subscription. And then they need authorization. Their developer needs to be able to be authorized to deploy to that subscription. So the participants will write the developer's name and assign them a role on the subscription in the Azure Resource Manager, which is represented here by a bouncer for that authorization to get in. From there, in order to have authorization, you have to have authentication. So the participants introduce Azure Active Directory, which is presented to them as a list of names and a list of groups. And it's a really clean example of the premise of authorization authentication. Through further provocations in the story, our participants start developing and deploying resources and running their code on an application and using storage and all of these things to store their data. And this is going fine until another developer is put onto the project. And this is the point where we have to talk about environments, because if two developers are working into the same environment, they might start clashing. So we start looking at duplicates of the system that allow our developers to work in isolation. But manually configuring separate environments is really error prone. And we actually have these, our delegates manifest these errors by putting bits of paper in the wrong place or forgetting a bit of it. So they get a real kind of feeling of what it is to manually configure an environment and part of some of the problems with it. So this lets us introduce infrastructure as code, which we closely couple to our application code because they have the same life cycle and they change together. And we blue tack these pieces together to show that we hold them as one unit. Once we've got infrastructure as code, we can introduce pipelines with a build pipeline and a release pipeline to different environments. And this gives us ultimately, through several other steps, a picture of Azure where we've got multiple systems, some of which with many environments. And our delegates have built an entire cloud system without ever having touched the cloud. So this is super powerful. This works really well in person. And we ran it about 20 times before the pandemic hit. It was really well received. Because it's on paper, it does not translate at all well to the remote or hybrid world. And so we were a bit stuck. But then one of our trainees took this piece of work and with another colleague refined the content and actually made us a digital version, which has a drag and drop interface that you can sort of see being demonstrated here. And I will share a link to this at the end of the talk. Missed one. There we go. Cool. And the next example I kind of want to walk you through is the Pizzeria. So the Pizzeria is a software engineering, an object-oriented, test-driven development, software architecture kind of worked example, where through the context of running a pizzeria, where pizzas are ordered, created, and delivered, our participants learn about lots of different aspects of software development. So I'm going to take you through a bit of a journey of what that looks like. And this is very programmer friendly, so please do bear with me. So we start with a console project, a console app project. Now this teaches our developers how to do manual testing to start off with, the simplest type, to just run the code and make sure it kind of does the thing you vaguely expect it to. And then we start ordering pizzas, like a cheese, tomato, ham, and pineapple pizza. And we look for the pizza to come back with those toppings, and we can manually inspect it on a breakpoint. And then we look at like, okay, people don't typically order a comma-separated list of pizza toppings. So we invite the trainees to look at, can you make me a Hawaiian or margarita pizza? And this sort of takes us through if statements and switch case statements. Having done those tests manually, we now look at how can we automate those tests, and that introduces our test framework. And then we extend it a bit. So we say that pizza has to be put into an oven, but because we don't want to create an oven every time we create a pizzeria, we look at dependency injection. But then we introduce some realism into our oven and we make it take a little while to cook a pizza. And this isn't great when you're running tests because you're waiting minutes at a time for your pizzas to come out before your next test will start. And this lets us introduce test doubles and particularly stubs. So having a pizza that instantly returns when you're running tests that aren't actually about the oven itself. Then we introduce an order up bell. So the bell gets rung every time a pizza is ordered. And this is a behavior test. We're looking for the pizzeria to ring the bell, which brings us into test doubles and spies. We look at separation of concerns by hiring a chef so that the person taking the order on the pizzeria, taking the order of the pizza in the pizzeria, is no longer the person creating the pizza as well. We separate those concerns by introducing a chef. And then the trainees take a break, and I go and break their code in a couple of places. So their end-to-end test fails, but they find that they don't have enough test coverage to understand exactly where the problem is. And this starts introducing test coverage and triangulation. And then we go into delivering the pizzas. So we write it out to file by delivering them to Fileville. Once we've got 2 ways of delivering a pizza, we start exploring inheritance, and we start writing them to Azure storage tables into Tablehampton, and by car to Westminster, because I'm hilarious. And this, we build this big kind of project out of it. And that gives us enough for us to start seeing patterns in the code, seeing some of the duplication and exploring different things. So we see that we introduced a test double library called mock, which is C#'s main mocking framework, test double framework. And we sort of see the patterns of this sort of pizza translation into different things, whether it's files or tables or to REST, and it introduces us to ports and adapters as a software architecture. So this is another like clean example. Everyone knows what a pizza is, and most people have a concept of how a pizzeria must run, even if they haven't ever worked in one. And it really lets us focus on the programming aspects, the object orientation, the software architecture aspects, and makes for a really, really effective learning experience. And here is an illustration of our "it doesn't have to be perfect to be effective." And this is a picture that I have taken of the whiteboard that is across from me at work. And this is a representation of what we try and achieve with our time in the Engineering Academy for our trainees. And we try and teach them code. We teach them if statements and logic and loops. We teach them object orientation. And we put that in hexagonal architecture. That's one of our favorites, but we teach software architecture. And we teach testing at different scopes, including unit and system and integration. We look at execution environments, whether that's an app service, like a web app kind of thing, or virtual machines or Kubernetes clusters. And these are all platformed into Azure subscriptions, which are authenticated by Azure Active Directory and authorized by the role-based access control system, and where we have different types of storage and networking and all of these things, where we have pipelines to configure all of those things that we've just spoken about. And we look at the tools of the trainees themselves. So work management, which we typically do through Azure DevOps, and the tools in the toolbox. So PowerShell and Postman and Visual Studio Code and Git. And we look at the constructive working practices amongst the trainees themselves, how retros run and how stand-ups run and how to be an effective team player. So this in a diagram is a lot of what we do with the Engineering Academy. So this is kind of what goes into it. We're really intentional about our recruitment. We get our trainees working on real work that's important and not urgent, so that they can take the time, so that they're delivering value all the time. They're working on real work that has value, but it's not so urgent that they can't learn from it. And we support them with targeted teaching interventions that really, really pick on the things that we think are very important, and support them with our established engineers. And through this, we end up with software engineers, or test engineers, or data scientists. So in terms of timelines, it's a very big it depends as to how long does it take for someone to become effective, someone to become independently effective, to become a software engineer. So it depends is a frustrating answer. So I'm going to give you some numbers, but with a very low level of confidence about their wide applicability. It really does depend on the candidate, on the work, on what's going on in the organization, all of those things. But as a very rough metric, we kind of see trainees starting to deliver independent pieces of work, small features with support, or at least on the sort of breaking it down kind of thing, at around about 3 months. It can be a really, really fast return. around about 10 months, they are able to deliver projects that are sort of multi-featured, maybe not ones that like really weave into a complex, that are multi-featured, like small software systems are definitely achievable in 10 months. Around 14 to 16 months, we kind of expect them to be coming along to the status of engineer. So at 10 months, we might progress them to associate engineer, which is our junior engineering level. Around 14 to 16 months, give or take quite a bit, we might expect to progress them to software engineer. This might sound a bit like the graduate scheme or the government's apprenticeship scheme. And we do have both of these in play, but they are neither, but our trainee scheme is neither of these things. So we have graduates on a grad scheme, and they cycle through the business into different departments, including into T&D. But the grad scheme is oriented around a sort of business focus. So how does the whole business fit together? Whereas the trainee scheme is focused and targeted to our technical specialists. And there's the apprenticeship scheme. So we have a couple of apprentices in the building. We have a business analyst apprenticeship going through at the moment. But we have looked at this several times and will continue to look at this. But at the moment, the apprenticeship scheme doesn't give us the flexibility that we need and doesn't complement what we are trying to achieve. So we do go around on the loop on this periodically because it's something we'd like to take advantage of, but it's a not yet for us. And there's always going to be a question these days about retention. And before the pandemic, our retention was very, very good. Building skills and having those teaching and learning relationships builds a lot of social capital, a lot of loyalty, and people feel really invested in their roles with us. Post-pandemic, I would say it's still too early to say. We haven't been immune to the Great Resignation, though my anecdotal experience is it's not very many of our early career engineers that are flying the nest. It has hit us a bit harder in that sort of mid-tier engineering level, but it's TBC, still very early to say. We don't seem to have a retention problem with our trainees. So I have whistled through this, finishing a little early, but to sum up, growing talent is a long game, but we find it's worth it. We have built some really, really talented engineers who are delivering value for the Ordnance Survey, and it's been an absolute pleasure and privilege to work with them. So thank you very much for your attendance. Thank you very much for bearing with me. I have a set of links to share with you into the chat, and I'm very happy to take whatever questions you have.